Hello student, today I am going to discuss Heisens Principle and also using Heisens Principle I am going to prove laws of reflection of light. Let us discuss at first Heisens Principle. What are the statements of Heisens Principle? Number 1. Each source of light is a center of disturbance which waves spread in all directions. All the particles equidistant from the source and the vibrating in same phase lie on a surface known as wavefront. So according to first statement, so each source of light is a center of disturbance and it spreads in all direction, and all particles from the source all particles from the source are equidistant and vibrating in the same phase and lie on a surface. This surface is known as wavefront. So this is wavefront. This is number 1, first statement. Second statement, every point on a wavefront is a source of new disturbance. So here 1, 2, 3, 4, these are the point. Every point on the wavefront is a source of new disturbance which produces secondary wavelets. These are called secondary wavelets, which produces secondary wavelets. These secondary wavelets are spherical. These secondary wavelets are spherical and travel with the speed of light in all directions in that medium. So according to second statement of Heisens Principle, every point on the wavefront is a center of new disturbance which produces secondary wavelets, and these secondary wavelets are spherical and travel with the speed of light in all directions in that medium. Number third statement, the forward envelope. This is the forward envelope enclosing the tangent at the secondary wavelets at any instant gives the new position of the wavefront. So this forward envelope, this tangent, so this tangent drawn, so this is the new position of the wavefront. So here we have shown two diagram. One is for near source, one source is near, another is when the source is at far distance, then the wavefront will be like this. Now we will discuss laws of reflection of light on the basis of Heisens Principle. Here you see the diagram. Here considering a reflecting surface xy is the reflecting surface on which a plane wavefront AB is the plane wavefront, is incident at A. So according to, just now we have discussed, according to Heisens Principle, each point on the wavefront acts as a source of new disturbance. So here every point on the wavefront is a center of new disturbance which produces secondary wavelets. So here AB acts as a source of new disturbance. Let the secondary wavelets B recess C on the reflecting surface and it travels a distance. You see, when B reaches to C, then A reaches to D. So ultimately they are traveling AD equal to BC. Here A acts as a center of radius AD or BC or BC, AD or BC. And a sphere is drawn. This is the sphere with respect to center A or B. So A with respect to A, this is the radius. AD is the radius. A sphere is drawn. This is the sphere. A sphere is drawn. Now tangent is joined to the sphere at D. So this line is drawn. Tangent is drawn at point D. Okay. CD is the reflected plane wavefront. CD is the reflected plane wavefront. So we know, according to laws of reflection, the angle of incidence is equal to angle of reflection. That is I equal to R. We are going to prove this one. I equal to R. Now, time taken by wavelets to reach from B to C or from A to D is given by T equal to time distance by velocity BC by C. BC distance is BC by C. C is the speed of light, or AD by C, where C is the speed of light. So here C cancels, so BC equal to AD. Let's give the equation number 1. Now from triangle ABC, this is the diagram. ABC is a right angle triangle. With respect to I, the angle of incidence, with respect to I, BC is perpendicular, AC is hypotenuse. So you can write sin BC by AC equal to sine of I. That is BC equal to AC sine of I. Equation number 2. Also, from triangle ADC, again you see diagram ADC. So ADC is right angle triangle with respect to R, angle R. So AD is perpendicular, AC is hypotenuse. So perpendicular by hypotenuse, AD by AC, this sine of R, AD equal to AC sine of R. This is equation number 3. Now substituting for BC and AD from equation 2 and 3 in equation 1, we get BC is AC sine of I and AD equal to AC sine of R. So AC cancel, sine of I equal to sine of R, I equal to R. That is angle of incidence equal to angle of reflection. Hence angle of incidence is equal to angle of reflection which is the law of reflection. So this is the proof, angle of incidence equal to angle of reflection. This is the law of reflection of light. Thank you.